0, 0. Tell me about the direct, or the width. 135, dot, dot, dot. So if you don't remember any of that, you can always graph a base graph just by using a table of values. So I'll show you for the first one. So even if you don't remember what a parabola looks like, we're just going to pick generic x values. I'm going to pick -2, -1, 0, 1, 2. Why? I don't know. Just feel like those numbers. And then we just substitute them into the function. So -2 squared, 4. -1 squared, 0 squared, 1 squared, and 2 squared. And then we're just going to plot the points. So -2, +4, -1, +1, 0, 0, 1, 1, 2, 4. Okay, so even if you didn't remember the base parabola, you can always figure it out just with a table of values. And we know we have our parabolic shape or our U shape. If that doesn't look familiar, you probably didn't take 30 pre-cal, just saying, because that was like in 4 units. I'm going to go down to absolute value. What does an absolute value do? Why? Why? Because that's what you told us last year, Ms. Thompson. Why? Why? What does it represent? What does an absolute value mean? Why? If you think of a number line, absolute value represents the distance between 0 and that number. So if I said -3, the absolute value of -3 represents the number of units between 0 and -3. How many units? 3. A distance can't be negative. So that's why it turns positive, is because it represents a distance. So -2, if we put into the function, absolute value of -2 means how many units are there between 0 and -2? 2. Absolute value of -1 means how many units are there in a number line between 0 and -1. Absolute value of 0 means how many units are there in a number line between 0 and 0? 0. Absolute value of 1. Absolute value of 2. Okay, so plotting the points, -2, +2, -1, 1, 0, 0, 1, 1, 2, 2. And we are not barbarians, so we use rulers. We don't like messy graphs. Keep in mind, mathematicians, not creative people. We call this one a U for the obvious reasons. What do you think we call this one? The V. And next unit, you'll meet the W. Does that vaguely look familiar from last year a little bit? Okay, again, if you ever forget, just throw in table of values, get some points. Okay, going up to square root of x. This time I'm not going to start with -2 because it's not a great value. If I were to sub in -2, what happens? What's the square root of -2? It doesn't exist. It's impossible. So I can't use -2. What about -1? No. So what's the smallest possible value I can use? 0. Square root of 0 is? Okay, 1 is a good number. What's the square root of 1? 2, not so good. Why do I probably not want to pick 2? Yeah, and what's the square root of 2? 1 point stuff, right? So we don't want to have to plot that. What about 3? Okay, so what's the next really good value? 4 is a good value because square root of 4 is? What would be another really good value? 9. Square root of 9 is? 3. Okay, so it starts at the origin at 0, 0, 1, 1, 4, 2, 9, 3. And this is where you can use those tickies at 5. So instead of counting 9 over, you can find the second ticky, which is 10, and then subtract 1. The U, the V, want to guess? It's a swoop. It swoops to the right. Yep, it's a swoop. Very technical math term. Some people, it bothers them that the end of the graph is just kind of hanging around here and it seems like it just stops. So if you're visual, sometimes making a darker point just helps you remember that that's the end of the graph. There's nothing past that. Why is there nothing past that? Can't square root a negative. Okay, cubic is new. Same values, -2, -1, 0, 1, 2. After we draw it, don't shout it out, but I'm going to have you think about what do you think we call this graph. Remember, we're not creative people. We don't use the right side of our brain. We're very logical people. -2 cubed, so -2 times -2 times -2. -8. -1 cubed, so -1 times -1 times -1. 0 cubed, so 0 times 0 times 0. 1 cubed. 2 cubed. Okay, plot the points. So -2, -8. -1, -1. 0, 0. 1, 1. And 2, 8. Don't forget arrows on the end, just like the parabola or the absolute value or the square root. They go on forever. Turn and tell someone what you think we're going to call this. Turn and talk to each other. Turn and talk. I know it's scary. So lots of people will say S, but it's not really kind of an S because it's backwards. Bent line would be creative. No, we're not that creative. No, now you can tell me. Now you can tell me. Noodle would be good. What now? More obvious? Propeller. Oh, that's too creative. No, we're much more logical. If this was an animal, it's a snake. This is a snake graph. So we have the U, we have the V, we have the swoop, we have the snake. Okay? These are called base graph or parent functions because they don't have any other numbers. Okay? They don't have a 2 in front or a +7. There's nothing going on. Keep this beside you. It's going to be our reference sheet for the whole unit. Unit 3, transformations. Look at all the good stuff we get to do here. Today we're going to do what's called translations. Can you count? Do you know your left from your right? Do you know what direction is up and which is down? Then you can do translations. You need to know those 3 things: how to count, your left from your right, up from down. Then on Monday we're going to do reflections.
You mean Tuesday?
Yes, Tuesday. I'm eating pumpkin pie on Monday. It's great. It is the greatest thing ever. Have you had Sergeant Sunday pumpkin pie ice cream? Oh my God, you have to go and have it. It's like the whipped cream and the pumpkin pie all together. Oh. Then we're going to do something called compressions and stretches. So we're going to take graphs and pull on them and squish them and sit on them and yank on them. We're then going to combine those 3 into one. Then we're going to show you a new kind of function that's called the inverse function. It's pretty cool. And the last 2 things have to do with what's called sinusoidal functions. Let me say that again, sinusoidal. What's the first 3 letters you see? Sine, cos, tan are back. And their friends, secant and cosecant and cotan. All back. Tell you, don't ruin it. Don't ruin it for them. I know, they're kind of fun, right? Don't tell the others. Don't tell the others. Let's just go back to grade 11 in our heads for a second. So let's go back and talk about parabolas. Nothing new at this point. Tell me, what's the vertex of the base graph? And last year we looked at what happens if we add 4 to it. So we know the x value doesn't change, y value becomes. And then we got crazy. We're like, let's subtract a number. And we figured out the x value doesn't change, but what happens to the y value? Goes down too. So we didn't talk about it last semester in these terms, but anytime you add or subtract a number on the end, it's called a vertical translation. Vertical translation. A synonym for translation is a shift. So all we're doing is just moving this parabola up and down. Parent. And then we looked at, okay, let's get really ninja crazy town and let's put a number inside the brackets. And this was the one that was kind of funky because it ended up doing the opposite. So if we put -5 here, what happened to the vertex? It was +5. So this one would be 5, 0. And then we learned if we put a positive here, what happened over here with the vertex? -7, 0. And so then we talked about if we add or subtract a number inside the brackets, we call it now a horizontal translation. So these kinds of transformations are called translations, and they can be applied to any kind of graph. We only did quadratics last year because you were just babies at math, but now you're not. We're going to do it with square roots and absolute values and cubics and all these other great functions. That's all we're going to do today is pick up graphs and move it. If you can count and you know your direction, this is super easy. So the general vertical translation we call y equals x squared minus q, yq. I don't know, somebody picked it. It's just a number. And the horizontal we call y equals open bracket x plus p squared. Why p? I don't know, because it's kind of funny when you say p. Somebody just picked it. It's probably y because it's funny. And the trick with this is to look where the difference between these two are. This one has no brackets. This one has brackets. Here we are adding or subtracting outside the x squared. Here we are adding and subtracting inside the x squared. So a vertical is always outside brackets. Horizontal is always inside brackets. Ooh, inside. I'm probably going to say this 200 times this unit. Vertical is outside of the brackets. Horizontal is inside of the brackets. So we're going to do a bunch of different things today. The first, I'm going to give you an equation. We're going to identify and describe the transformation, so just talk about what's happening. Then we're going to go backwards. I'm going to tell you the transformations. We're going to write the new equation. Then we're going to actually get into some graphing. Describe is the key word I want you to highlight. Describe to a math teacher, very different than describe to an English teacher. Describing to an English teacher is like a paragraph and lots of fancy words. It's not that way in math. Describing is you name it and you tell me what it's going to do. You name it and you tell me what it's going to do. So I'm going to go to the two first. Is it inside brackets or outside brackets? Inside. So that means it is a horizontal translation. Look at that. How did I name it? With 2 letters, that's it. What's an HT? Horizontal translation. We're even too lazy to write up the whole world. HT tells us enough it's a horizontal translation. The second thing is you need to tell me what it does. You need to tell me the direction and how many units. So this is going to be 2 units. If it's positive in the brackets, what happens to the actual graph? Does it go to the left or go to the right? It goes to the left, and here's how we show that. That is describing, I kid you not, HT, 2, and an arrow to the left. That tells a mathematician it's a horizontal translation 2 units to the left. You can. It's just we try not to use words because we don't like them. They scare us. So if it's positive in here, it's to the left. If it's a negative, it's to the right. Oh, I just didn't get to them yet. I'm going to do them right now. So the -5, is it inside brackets or outside brackets? That means it's a vertical translation. That's naming it. Now you have to tell me what it does. It's going to be 5 units down. Why is it down? Because it's negative. That's describing the transformations. That's it. There's no words. There's no paragraphs. There's no 3-paragraph essays. That's it. That's all we need. Now we're going to go backwards. Here's the description. I want you to give me an equation like this. Okay, so it's told us 3 units up, 2 units to the left. Oh, I totally forgot B. Yes, I was so excited. Let's do B. How about that? Let's start with the -3. Because it's negative. This is horizontal, so it goes side to side. Vertical is up and down. Okay, -3. Inside brackets or outside brackets? That means it is a 3 units to the right. Remember, it's the one that's backwards. It's negative, but it ends up going to the right. The -5, is it inside brackets or outside brackets? Outside, that means it is a VT, 5 units down. It's exactly what it was with parabolas. All we're doing is we gave you a cubic for the first one and a square root for the second one. How about now we do number 2? Okay, so they've given us the parent graph or the base graph or parent function, y = x cubed. They've told us it was translated 3 units up, 2 units to the left. So what we need to do is make the equation look like this. Oh, Tina, sorry. Yes. So that's why it went to the left. Left is negative direction, but it's positive. Nope. So I'm going to keep the y. I'm going to throw in some brackets. I'm going to put the x in brackets, and I'm going to put the cubed on the outside. How do I know that I'm going to need brackets somewhere in here? Because left implies what direction? Horizontal. Up implies vertical. So I know horizontal is going to go inside the brackets. If it's to the left, what number do I end up putting here? +2. The vertical is going to go outside, and if it's going up, +3. That's it. That's all that question is asking for. A little sleepy there, Jenna? Okay, let's do some actual graphing. I always forget about the domain and range, so someone needs to remind me because I get so excited I just go on without them. So at the end, remind me domain and range. Sketch the following graphs. First one is the absolute value of x + 3. State the domain and range. Step number 1, take away the numbers. You just want to leave the symbols and the x and the y and tell me which of these parent graphs or base graphs, if I take away the numbers, am I dealing with? Absolute value, and I heard parabola. Has to be absolute value. So if we look at the equation, I take away the 3, what's left? Absolute value of x. So the very first step is we're going to draw the base graph for the parent function. Okay, if you don't remember what it looks like, that's why we have the little cheat sheet. So -2 and 2, -1 and 1, 0, 0, 1, 1, 2, 2. Rulers, I'm not marking messy, yucky graphs. So step number 1, we drew the base graph. Step number 2, now we're going to describe the functions. Is the 3 inside brackets or outside brackets? That makes it a horizontal translation. Now we have to tell me how it moves. 3 units to the left. So step 2 is to describe the transformations. Step 3, we're actually going to draw the transformations. Now what's going to happen near the end of this unit is we're going to have 4, 5, 6, maybe up to 8 different graphs on the same set of axes. If you make a mistake, it is impossible for me to find it. Even if you don't make a mistake, sometimes I can't see what was the original, what was step 2, what was step 3. So whatever is your final graph has to be in red. Red does not mean blue, it does not mean pink, it does not mean purple, it does not mean black with a little note, hey, Miss Thompson, this is red. Red means red. If you do not have a red pen, I have red pens right here in my bucket you can borrow. If there are no red pens, I have markers and pencil crayons up on my shelf. If you need to get a red pen, do it now. It's always the boys, just saying. It's always the boys. Yes, you can. Thank you. I'm going to repeat that. Whatever is your final end graph, the end of the question has to be in red. And there's 2 reasons. Number 1, because if you make a mistake, I can't find it. Number 2, in a second when we do in domain and range, it's going to be easier to tell if the graph is red and jumps out at you. Question or just no? Who, what, huh? Not black, not purple, not yellow, not orange, not a no, this is red. Red is red. So all I'm going to do is take those same 5 points in order left to right, and I'm going to physically move them 3 spots to the left. I'm not going to move them up or down, I'm just going to move them to the left. So I'm at negative 2, 2, and all I'm doing is counting 1, 2, 3, and putting a dot. And the second point is negative 1, 1, and I'm just counting 1, 2, 3 to the left and putting a dot. And then the third point is the origin. I'm counting 1, 2, 3, putting a dot. Fourth point, 1, 2, 3. And the fifth point, 1, 2, 3. Seriously, if you can count, you can do translations. Join them with a ruler, because we are civilized people who make nice graphs. And there's your first translation. Absolutely, yeah. Exactly where we started with parabolas last year, we're just doing it with different kinds of functions now. So this is how we started parabolas. We move them over, we move them up and down. Same thing, we're just doing it with an absolute value this time. How are we feeling? Is there anything you want to remind me about? Domain and range, very good. Last year we learned 2 different ways to state domain and range. Apparently one class didn't learn 2 ways. You're not going to freak out on me if you don't know it. I'm going to teach you now. You can pick whichever one you like, but you can't mix and match. So whatever you use for domain, you have to use for range. So domain are left to right. Ranges are up and down. Domain is all the possible x values. Range is all the possible y values. Easiest way to remember it is what comes alphabetically, domain or range. Domain. What comes first alphabetically, x or y? X. So domain goes with x because they're alphabetical. Range goes with y. Really, Zach, how old are you feeling today? When it asks you for domain and range, it's asking for the last graph. That's the second reason I want it in red, because if we were to have 8 of these on the graph, it's really hard to see which is the last one. So we look to the left first. What does an arrow mean? Goes on forever and ever and ever. So what's the smallest possible value on the left going to be? Negative infinity. And we look to the right, and what does the arrow mean that's on the right? Forever and ever and ever. So what's the highest value we're going to see? So if you like interval notation, we write that as negative infinity, infinity, and we use round brackets. That's called interval notation. If you like set notation, we write that as x, e, r. Ooh, where have we seen something like that before? KES, right? And somebody said yesterday, is that the same thing? No. Reals is r, so it means any kind of number. As z or the I is just the integers. Range, we look down and we look up. So if we look at the bottom of the graph, we don't have an arrow pointing down. What that tells us is we have a stopping point. Where's the very lowest point on the graph? Where do we run out of graph? 0. What's the highest point on the graph? Infinity. So if you want to match interval notation, we say that that's 0 with the square bracket to infinity with a round bracket. If you want to use set notation, we say y is greater than or equal to 0. You can pick and choose, so if you like interval, use interval. If you like set, use set. You can't mix and match. You can't put a YER with a 0 to infinity. You can't put a negative infinity to infinity with a y greater than or equal to 0. They come together. Whew! Does that kind of bring it back from last year? It is a package deal. Ooh, a cubic. I sense you're mocking me. Notes. And you know when it's in red and has note with an underline, it's really important. The provincial exam peeps will try to get a little tricky here, but you're too smart for them. And they'll try to put this little 1 on the left-hand side. So the note is going to be all the numbers need to be on the right-hand side. So you always need to isolate y. So however you choose to word that, so it can be isolate y. Move everything to the right-hand side. Get the y by itself. Whatever makes sense in your brain to know you need the y all here, everything else on the other side. So I remember with isolate y. If that's not clear to you, write whatever you need. Well, why is that so important? We know if we move stuff from side to side, it's not really changing the equation, but watch what's going to happen. How do I get rid of a +1? And suddenly now we've taken it from what looked like a vertical translation up to a vertical translation down. And that's why it's really important everything's on one side, because it may trick you into thinking it's the other direction. Step number 1, base graph. So take away all the numbers, leave the variable, leave the exponent. So if I take away the 2, the -2, and I take away the -1, what is left? X cubed. Okay, look at your cheat sheet. Which of these is x cubed? The cubic. So draw me the base graph of the cubic. Slippery snake, yippers.